So in this video, I'm going to go over our second homework on discrete random variables. There's a problem here about a basketball player shooting free throws and a problem about flipping a coin. And then after I go over the homework, and I'm going to extend beyond it just a little bit to talk about the binomial distribution, which will give us some solutions to problems, a lot of different problems of the same type, where there are just two different alternatives. When the basketball player is shooting the shots, it's either success or failure on each shot, or flipping the coin, it's either heads or tails. You might be asking a survey in a population, asking a yes/no question. And so we're going to try to get a handle on all problems of that type. Okay, so for the basketball player, so it says his probability of success on each shot is 60%, independent of his success on any other shots. So it's not like, oh, if he misses one, then the next time he's less likely to hit because he's upset. It's not like that. They're just independent. Every shot, 60%. That's our model. Okay. Now, so assume he shoots 3 shots. Okay, and X is the number of successes. Okay, so we have a repeatable experiment here. So our repeatable experiment is shoot 3 times. And we shoot 3 times and record something about what happened. Okay. And what are the possible outcomes? So before I even try to solve the problem to write down the probability distribution, I'm just putting the thing into the framework, that we've set up for how probability works, where we have an experiment and we have outcomes and we have a probability model. Okay. So you shoot 3 times. It's either success, success, success. Okay. Or succeed, succeed, fail. Okay. So we did our SS, two outcomes that begin with SS, 2 outcomes that begin with SF. Now we'll do the ones, the FS. Okay, so we have 8 outcomes. All right. And now, what's the probability distribution of X? Well, what's X? Okay, X of an outcome So our random variable X, a random variable, you give it the outcome from an experiment, and it gives you back a number. Okay, so like for this one, like for example, X of so how many successes were there if you shot SSF, that would be 2. Okay, so X is the function that gives you the number of successes. Okay, now, what's the it's asking us to write down the probability distribution of X. So what's a probability distribution of a discrete random variable? So we come back up here to get the definition. What is it that what's it asking for? And so it's a listing of the range of X, okay, all the outputs that are possible from X, along with the probability for each one. So the values of X along with the probability for each one. So my probability distribution of X I'm going to list the possible values of X. I shoot 3 times, maybe I miss all 3, and so X would be 0 successes, or I could have 1 or 2 or 3 successes. So X1 is 0, X2 is 1, X3 is 2, so forth. And now I need to work out the probabilities for each of those. Okay. So I'm going to go off to the side and I'm going to figure out how likely is each one of these possible outcomes. What's the probability for each one of those? So the probability of the event that you hit all 3 of them, well, 60% of the time you hit that first shot. Okay, so like out of 100 shots, maybe you expect to get 60 of them. And then, but you shoot 3 times. So now when you come to the second shot, 60% of the times when you got the first shot, you also go on to get the second shot. So of those 60 repetitions of the experiment, okay, a repetition is you shoot 3 times, okay, so out of 100, you expect 60 of those 3-shot trials, you got the first guy, and 60% of those, you also got the second shot. And so we're down to 36% of the time, you've made both of the first 2 shots. And then, but do you go on to make the third shot? Only 60% of the ones where you made the first 2. So it's 60% of 60% of 60%. Okay. Now, what's the probability that I get succeed, and then fail? Okay, so So 60% of 60%, 36% of the time, I hit those first two shots, and then 40% of the time I miss the third one. And so forth. So if it's in a different order, SFS, okay, so I say 0.6 times 0.4 times 0.6, but the order of multiplication doesn't matter. It's still two successes and one failure. Okay. So, what's the probability that I get 0 successes? That's easy. So the probability that x equals 0 is the probability that the outcome is FFF so that's 0.4 times 0.4 times 0.4. Oh. Okay. Now what's the probability of one success? The event that you have one success has 3 different outcomes in it. It's this one, you could succeed on the first shot, or you succeed on the second shot, so there are 3 ways that could happen. So the probability of, make the union of 2 or 3 disjoint events, you add up the probabilities of the pieces inside. The probability that this or this or this happens, this happens a certain percent of the time, and this happens a certain percent of the time, and that happens a certain percent of the time. So you add those 3 together, and that's how often you get, one or the other of them. So that's Kolmogorov's axiom 4, that you add probabilities for disjoint events. And then, well, these are all the same. It's They say it's 3 because there were 3 ways it could happen. And it was 0.6 to the first power because we're talking about one success. And the 0.4, if it was 60% probability of success, it was 40% probability of failure. So that's where the 0.4 came from. It's 1 minus p. And what's the power? I'll say n minus x. N is because we took 3 shots. So now, and this, the 3 here and the 3 there is 2 different 3s, right? We took 3 shots total. But then there were 3 ways that you could get this particular x value. Okay. But anyway. So we can write this up here. 3 times 0.6 times 0.4 squared. And then to get 2 successes, there were 3 ways that could happen. And then to get 3 successes, you hit all 3, there's only 1 way that could happen, SSS. And so we can get our numbers. So there's my 0.4 cubed. Okay. And so we can get the numbers. And then the solution to the exercise is just the list of those. So anyhow. Those ought to add up to 1 or 100%. Yes, they do. Okay. So all that's left for us to do now is to just fill in the answer to the question over here. There it is. I need some equals marks. So that's the probability distribution of the variable. Okay. Now let's do the same thing for this question 2. And where people really got stuck was actually question 2b. So here's our formula for the mean of a probability distribution. And for the number of x equals 1 if heads comes up, and x equals 0 if tails comes up. So here's our distribution. So there are two different values of x. x1 is 0 and x2 is 1. And it was x was 0 for tails and 1 for heads. The probability of heads was p. Okay, so there's our distribution. So we do P1x1 plus P2x2. That's 1 minus P times 0 plus P times 1. Zero plus P. So mu is P. So if we're predicting in the long run, if we flip many, many times, you get a bunch of 1s and 0s, add them all together, divide by how many times you flipped. A prediction is that'll be close to P in the long run. Okay. Now for the standard deviation. So we'll have, and then there's a big square root on here. I'm going to do sigma squared first, and then when I get to the end, I'll take the square root and just have sigma. Okay, so I have P1 x1 minus mu squared, and P2 x2 minus mu squared. Okay, P1 is 1 minus P. X1 is 0. Mu is P from the previous question. Okay, mu was P. X1 is 0. Okay. P1 is 1 minus P. Then here's our P2, that's P. X2, that's 1. Mu is P. That's squared. And now just do the arithmetic. So 1 minus p, you probably remember FOIL, 1 minus p times 1 minus p. 1 minus 2p plus p squared. First, outer, inner, last. Okay. So we have this, and fortunately it simplifies a little bit. The p cubed and the minus p cubed go away. And then there's a p squared minus 2p squared. So I got this p guy here, and then p squared minus 2p squared is just minus 1p squared. I'll factor it out, it doesn't matter. So that's sigma squared. So the standard deviation. This up here is the square of the standard deviation. That's the variance. The standard deviation, you just take the square root of the variance. So there we go. So the distribution mean was p, and the distribution standard deviation was square root of p times 1 minus p. And I did the work over here. Probably, you know, when you want to hand these in, you can either sort of abbreviate this and type it out, or you can say attached, and you can always in the comments section of the of Canvas, you know, after you hand in an assignment, if you want to attach comments, you can attach a file so you can have an image of the work. But that's it. Okay, I think I'm going to leave it off for this video, but I need to. Well, let's go ahead. You can generalize. Okay, so I really can just add one line down here at the bottom of what we did with the probabilities for the shooting free throws. Okay. So for the binomial distribution, it's binomial. It's like, it means two-way. It's always a situation where it's like shooting the baskets, either success or fail, or asking a yes/no question on a survey. Okay. So you do so like shooting the basket 3 times was 1 repetition of the experiment. So So 1 repetition of the experiment is to do n different trials with yes/no outcomes. So one repetition of the experiment might be to select 100 random people and ask them, did you vote? Okay. And so our variable x is the number of yes results that you get. And just like we did over here with our shooting the baskets or flipping the coins or whatever. See, I had this 3 here when I was getting the probability of 1 success, because there were 3 ways that could happen up here among our outcomes. And so to finish this formula, I just need to put in something here for the number of different ways. So it'll be pretty easy to see how this is. Let's say just to make it concrete, let's do with 6. Let's do with, okay, with 6 trials. How many ways to get 2 successes? You know, so it's like you take these 6 shots, so we take 6 shots, and now the question is, how many different ways can we arrange it? Now 2 of these are going to be successes, and the rest are going to fail. And so it's just how many different ways can we choose which 2 places to write the letter S. And so there's a lot of sequences, SS, FFFF, or SFS, FFF, and so forth. Lots of different ways you can choose where to put the S's. And so the way you do it, you just scramble all the pins up here. From a set of 6 pins, how many ways are there to choose 2 pins? So it doesn't matter what order I pull them out in. If I got these 2 pins, that tells me where to write the letter S. So it's just from a set of 6 objects, how many ways can I choose 2? Combinations. See, when I draw out the pens, it doesn't matter. I can't get the same pen twice. I need two different locations to write the letter S. So no reps. And the order doesn't matter. Even though I care about the order I write things in, the order, I've just got 6 different color pens, and the order that I draw out the 2 pens doesn't matter. So it's 6C2. So from n different trials, how many ways are there to get my, how many different order, arrangements can I do for the successes NCX? So that gives us our binomial distribution formula. And then it's real easy to apply, like shoot 7 baskets. What's the probability of 3 successes if each shot has let's say each shot has a 70% success probability. Yep. So this is N X X N minus X P 1 minus B. At this point, it's just a lot of arithmetic. I'd do it with Excel. I guess I'll leave off, but once you have the formula, these are easy. Okay, let's call it a day for this topic.